Okay, hello everyone. I think this is working. Sorry about the little problem there. So welcome to all of you. My name is Julie and I run a program called Discover the Universe, as you can see. And well, because this is a strange situation for everyone and school is canceled in many places, we thought we could teach your kids astronomy directly. Usually my job is to help teachers with astronomy teaching. So I usually talk to teachers and offer them some training and some resources for classroom activities. But because of the weird situation, we decided to offer something for kids directly. And we're improvising. We didn't have much time to get ready for this. There's Lindsay in the background who's helping me, and it's me presenting the content. So if you have any questions, you can see the chat. If you find the chat annoying because there's a lot of discussion, if that bothers you, you can close the window. Same on YouTube. You can also minimize the chat so you won't see everything that's coming. But if you do have questions, send them that way. Depending on how many people are live, we might not be able to answer all questions, but we'll do our best to keep you informed and answer some questions. So just quickly how this is going to work. Every day at 2 p.m. Eastern time for the next 2 weeks for sure. We'll see after that. We will be going live with some astronomy content, a mini course. And it seems like many of you are interested because there's a lot of people here. And okay, sorry, I'm just saying, I'm hoping that everyone is having issues with the audio. Let me know if you are. And yes, so it's live on YouTube, as many of you are joining on YouTube actually. And if it will be visible by the recording will be visible. So hopefully, if you can be there live one day, you can watch the recording. Okay, I think that's all I have to say in terms of logistics a little bit. Let's get started. Okay, so today the first topic, from the Earth to infinity. So this is me, I'm presenting today, but I will have guest speakers over the next few weeks. So anyway, we're working hard to create something interesting for all of you. From the Earth to infinity, I'm gonna make you feel very small as we go further and further in the universe. And we'll be watching a lot of nice pictures as well. Just so you know, I will add content and resources for you to browse and other things to look at on the internet, on the website, where we put the information for this, Astro at home on the Discover the Universe website. I didn't put any videos because I wasn't sure how it would come on online through the streaming, so it's mostly still images. But let's start with this beautiful image of Earth. This is actually an image that was taken yesterday. There's a satellite that's monitoring the Earth every day, taking pictures of Earth every day. It's mostly for climate studies. This is an image where you might be able to see here North America, South America is here, and these are the Great Lakes. So I know I'm somewhere around here right now, but it's kind of fun. I'll send you the link to this website because it's great to see the Earth every day, how things change. But it's always a beautiful sight, I find, to see our planet from space and from far. It kind of gives us a different perspective on it. And to see it, with a dark background of space, a black background of space of the universe, it's very beautiful to look at. So this is our home. This is our spaceship. We're on it and we're traveling in space with it. We're actually moving very fast because the Earth is spinning, the Earth is going around the sun, the entire solar system is moving through the galaxy. So this is moving really fast, but we don't feel it. But it's kind of interesting to think of it as, we are on a spaceship. If I, ask how many of you would like to go on a spaceship, I'm sure many of you would raise their hands. But hey, we are on a spaceship already. So let's keep going. And this is, oh, sorry, I forgot to translate that little part. This is an artist impression. That's what it says in French at the bottom. Obviously, I did French this morning, forgot to translate that part. Sorry about that. But this is an artist impression of the solar system. And why do I say it's a drawing and not a picture? It's because the solar system, if you could see it, if you were in space and looking down on it, it would actually look pretty boring. It would look something like this. You might see the sun. The sun would be bright. You would see it. You might see a few other dots, which are planets reflecting sunlight. But that's kind of boring to look at. So it's much better to draw something like this. But this is not reality. The objects are not to scale at all. We don't have the orbits visible in space. But there's no perfect way to represent the solar system. So this is probably the best way to do it. But we'll have a look at the different objects in the solar system. And I really want to show you that the solar system is much more than just the planets and the sun. There are many, many interesting objects in the solar system. But the biggest objects are definitely the planets, other than the sun. Obviously, the sun is our star. Actually, let's go back to that for a sec. The sun is a star, just like all the other stars you see at night in the sky, except that it's much closer to us. And it is, it appears much brighter and warmer. But if we could travel to all the other stars, we would see that there are objects similar to the sun. So just keep that in mind. We'll come back to that a bit later. But keep it in mind when you look at the sun and everything that's around it, our solar system, this is repeated many, many times. Everywhere you look up in the sky and you see stars, all those stars have planets around. Well, most of those stars, the vast majority of stars we believe have planets and asteroids and comets around them as well. So other than the sun, the biggest objects actually in our solar system are the planets. We now say there are 8 planets. There are many more objects, as I'll show you in a minute. So here are the main ones in order from the sun: Mercury, Venus, Earth, Mars, and then the big planets, the gas giants, Jupiter, Saturn, Uranus, and Neptune. You can see that Jupiter is much bigger than the Earth. And in fact, this is not even the right scale. Relative to the size of the Earth here, Jupiter should be even bigger. So the planets are quite different from one another. It's very interesting to see the variety of planets we have just within our solar system. And now that we are looking at other planets around other stars, what we call exoplanets, we're discovering new types of planets completely. And that's a fascinating topic, and we'll hear more about it in the next few days as we have more presentations, and we'll definitely have one on exoplanets. So here's an image showing you many objects in the solar system. And while I'm talking a little bit about it, I want you to keep in mind that only 2 of these objects are actually what we call planets. Which ones? And how do you tell the difference, right? When you see this, it's pretty hard to know which ones are planets and which ones might be moons or dwarf planets. So this is something tricky, and this is why I see some people in the chat already talking about Pluto and why is Pluto not a planet anymore. It doesn't change anything to Pluto itself. It's just the category that we've decided to put it in. But here are the answers. So we have the planet Mars, and we have the planet Mercury. Sorry, I couldn't see something there. Mercury is here. And the other big ones you have are actually moons. So Ganymede is the largest moon in the solar system, and it's a moon around Jupiter. Jupiter has many moons, and the 4 biggest ones are Ganymede, Callisto, Io, and Europa right here. Titan is the largest moon of Saturn, and it is the only moon that has a thick atmosphere. So what you see here is actually the thick layer of atmosphere on Titan. Titan is a fascinating world. We don't always hear about it. Usually when we teach the solar system, we talk about the planets and the sun, but I tend to encourage people to look at other objects like Titan, a fascinating moon with lakes of methane. So it's basically natural gas, lakes, and rain. That the water cycle we have on Earth, there's basically a cycle like that on Titan with methane. So it's pretty weird to think about that. It's a fascinating world. If Titan orbited the sun, it would definitely be called a planet, but it orbits Saturn, so it's called a moon. But you can see Ganymede and Titan are both larger than the planet Mercury. Some moons in the solar system are also very interesting because they might have liquid water. Europa, moon of Jupiter, and small Enceladus right here around Saturn, they both have ice on the surface, and water ice on the surface, and we think there might be liquid water underneath. So that's a fascinating place. And we are definitely looking and studying a lot of trying to find ways to look at Europa and Enceladus and study them in more details, because they're some of the best places right now for possibility of life in the solar system. So places where there could be some life. We don't know yet. We don't know, right? But we're looking for places with liquid water and then we're trying to learn more about what's the conditions are exactly. I see there are lots of questions going on, but I see someone ask, what is the smallest exoplanet? So what's the smallest planet we've discovered so far? Just this field actually of discovering exoplanets is changing very rapidly. And I believe the latest results, if they're finding planets the size of the Earth, maybe even smaller, but the scale of the Earth roughly. But that was not possible just a few years ago. So this field is evolving very rapidly to discover smaller and smaller planets, again, outside our solar system. Just so you know, in this image here, we have Eris right here, and some other objects don't have real pictures. We know these objects exist, but we don't have clear pictures of them. So all the ones we have pictures of, that's because we've had a spacecraft that went close and took a nice picture of it. Okay, so anyway, there's a lot I could say around this. Oh, and actually, I see another question. How many moons does Jupiter have? And you know what? I don't even know the exact number because these numbers keep changing. I believe Jupiter is in the 70s or 80s right now. I'm not even completely sure. Once in a while, they find new objects and the count goes up. So some of you might know actually precisely, but you know what? That's the kind of information that's very easy to Google and go on Wikipedia and find a number of moons. But you realize, I know a lot of things in astronomy, but these details, because they keep changing and we're discovering new things, I don't always keep the count precisely. Okay, so we have other objects in the solar system too. These are asteroids. So asteroids are big rocks in space. They are smaller than planets and dwarf planets. To be a dwarf planet, coming back here, so Pluto, Aries, Ceres is right here, and other ones are called dwarf planets, which means that they are orbiting the sun. They're big enough to be spheres, big balls, but they are they're part of either the asteroid belt or the Kuiper belt. And I come back into the Kuiper belt in just a minute. We'll talk more about that. But Pluto, it's still, a spherical object. Objects that are even smaller than that, or smaller than many of the ones here, are randomly shaped, big rocks, and they are asteroids, and we can see some here. Just a quick note, as I see many people are raising their hands in Zoom, I forgot to mention it, we're not going to be using that feature, so there's no point raising your hand. If you have questions, again, things are happening in the chat. Yeah, there we go. Now, of course, I say that, and you're all trying it, because I see so many of you are raising their hands. But please stop doing it, because it's really appearing all over my screen right now. Okay, so asteroids are, again, big rocks, smaller than planets, different shapes here, but they are in orbit around the sun. We have other objects too that we call comets. And the name comet is pretty interesting because it means a hairy star. That's how they appear to us, and people have been observing comets for a long time. So in the sky, it looks a bit like this. There's sort of a star with long hair behind it. This is the first comet I've ever seen myself with the eye. It's pretty rare we can see a comet with the naked eye without any telescope or binoculars. This one was visible in 1997. I'm sure many of you were not born at the time. But when we sent a spacecraft to observe the comet core closer, it actually looks like this. So it looks a bit like an asteroid. If I come back to this, it looks a bit like this, a big chunk of rocks, either a big rock or smaller rocks all lumped together. But there's also a lot of ice. In fact, Comet is sort of a dirty snowball, a lot of ice and dust and small rocks. So when it gets close to the sun, the ice melts. It actually it's called sublimates. So it goes to gas directly, and that's what forms the tail. You can see some dust and material being ejected here. So what you see in the sky is actually not a big ball of fire. And next time you see in a TV program where they have a comet, I've seen that in cartoons very often, you see a comet, it looks like a ball of fire going through the sky. That's not what comets are. Comets are not made of fire. They're simply sort of gas and dust reflecting sunlight. And that's what we see. Okay, so I mentioned the Kuiper belt. I want to talk about it a little bit because this is something that's, in the last 20 years, we've really learned about this part of our solar system. So many textbooks don't mention it, but there's a lot of research happening, and it can help figure out why Pluto went from being a planet to a dwarf planet. Again, it's just a change of category. Pluto is still out there, same object as before. But a long time ago, we didn't know about all these objects here. So this is like a second asteroid belt beyond the orbit of Neptune. So in orange here, you have the orbit of Neptune around the sun in the center. This would be the orbit of Pluto. You see it's a bit inclined relative to the other ones. And now we're discovering more and more objects beyond the orbit of Neptune and Pluto. And some of them end up, we know, are about the same size as Pluto. So what do we do with those? We call them the 10th planet and 11th planet eventually. We decided to change the category and simply calling it dwarf planets. So big objects in the Kuiper belt, objects that are big enough to be spheres are now called dwarf planets when they are in the Kuiper belt or the asteroid belt. So that's why Pluto is now a dwarf planet, because it is part of the Kuiper belt. And Pluto, by the way, was visited by the spacecraft New Horizons a few years ago in 2015. Now New Horizons kept going, and it visited another object in early 2019. This was the furthest object ever visited by a human-made spacecraft, but you can see that we've sent other spacecrafts in space, and some of them are going pretty far now. So this is sort of the limit of the solar system. For now, there's more stuff, but when we talk about the size of the solar system, very often we kind of tend to think about the Kuiper belt as the limit. There's more. There are comets that go even further. But just so you get a sense of scale, what's beyond the solar system? Once you get beyond the Kuiper belt, what's there? It's actually empty space, and a lot of it. Just to give you an idea, imagine if you have a grapefruit, about this size, and this represents the sun. The Earth would be a grain of salt about 15 meters away. So that kind of gives you an idea. You have a grapefruit, and then you take a grain of, that's the sun, take a grain of salt, that's the Earth. You have to put it 15 meters away. The entire solar system up to the Kuiper belt would fit within about 1 kilometer of our sun. But that's pretty far if you think about it. 1 kilometer, that's a big chunk of neighborhood. And then where would be the next grapefruit? Where would be the next star in our model? If the whole solar system fits within 1 kilometer, you can sort of think about it for a second, but you probably won't get it right, because if you do the calculations, you end up with the next star, the next grapefruit, being about 4,000 kilometers away. So basically you would have a star in Vancouver, another one in Montreal. Each star would have its planet within about 1 kilometer around it, and then there would be a lot of empty space. And when I say empty space, it's really empty. There's not much there. There might be some molecules here and there. Some places in space have more gas and dust, but there's a lot of empty space, not air. No, not sometimes we think it's empty, but there's always air around us. Not air, just empty, nothing. So that's pretty amazing to think about, that how big space is, and the space between stars and planetary system is actually pretty huge. Just to give you an idea, this is a quick drawing just to show you the neighborhood around our sun. So the sun is here in the center, and you can see the scale here that kind of gives us a sense of scale. That's about 10 light years. Now, what's a light year? That's a unit of distance. That's the distance light travels in 1 year. And light travels extremely fast, 300,000 kilometers per second. To put that in perspective, it could actually go around the Earth 7 times, more than 7 times in just 1 second. So just imagine how fast you need to be to go 7 times around the Earth in 1 second, and that's how fast light is. In fact, it's so fast that you probably didn't even know, like it took some time. When you switch the light on, you don't realize that it takes some time for the light to fill the room, but it's a fraction of a second. So anyway, light travels very fast. Now imagine how far it could go in 1 year, and that's 1 light year. So it's an extremely big number, and that's 1 light year. Here we're talking about distances of a few light years between stars. So the closest star to the sun is the Alpha Centauri system, or the Proxima Centauri. You might see here both. Alpha Centauri is actually a triple star system. So 3 stars in orbit around one another. And the one star that comes closest to the sun is Proxima Centauri. So that's the nearest neighbor to the sun, over 4 light years away. And you can see here, we kind of represented the stars around the sun. The lines here just represent how high they are or above or below the plane that they drew there. But really the stars are here, and many of them are very small red stars that we can't even see with the naked eye. Actually, they're not very bright. But Sirius is the brightest star in the night sky. Tomorrow, we'll be showing you how to find stars and constellations in the sky. So we'll show you how to identify Sirius, actually, and Procyon is there also. So anyway, this kind of gives you an idea for, the stellar neighborhood, the neighborhood around the sun. Now let's zoom out a whole lot and have a look at our entire galaxy. 100,000 light years across. So that's a huge zoom out. It's a huge step from the image before. We're looking at an entire galaxy. And this is not a picture. Again, it's an artist's impression, a drawing based on the best knowledge, scientific knowledge of our galaxy. There's no way we could send a probe above the plane of the galaxy to take a picture like this. It's just way too far to do that. So this is, when we talk about galaxies, many of them are beautiful spiral galaxies. I'll show you pictures of real galaxies in a minute. But first, let's focus a little bit on our galaxy, the Milky Way. I do see a question about a black hole in the middle. We do think that most galaxies, in fact, we know there's a black hole at the center of our own galaxy. We'll have a session on black holes. I believe it's next Monday. Anyway, so I won't go into details of black holes too much, but we don't see it. We don't see the black holes at the center of galaxies. They don't emit light. And what we're seeing here actually are the stars around it. There are lots of stars above and below and all around, this plane, the way we see it here. So yes, there's a super massive black hole in the center, but we don't see it. We see the stars, lots of stars here, and sort of it forms a bar a little bit, and everything rotates, and it has this beautiful spiral shape. Now, in a galaxy, there are lots of stars, about 200 billion stars. That's a big number, but it's sometimes so big that it's hard a bit for us to comprehend how big it really is. So if you were to count to that number, you decide, hey, that's my goal in life. I'm going to count all the stars in the galaxy. And you start and you count at 1 per second. 1, 2, 3, 4. How long would it take you to count to 200 billion? For those of you, if you want to do it, you can enter 200 billion. So 200 plus 9 extra zeros on a calculator, and then divide by 60 seconds per minute, 60 minutes per hour, and so on. And you end up with a huge number. It's over 6,000 years. If you wanted to count to 200 billion, if you wanted to count to all the stars in our galaxy, it would take you over 6,000 years. So obviously, no one has counted all of them. The numbers I'm telling you, of course, approximate, and it's based on observations we make and calculations and math. There's a lot of calculations we can make. Actually, math is beautiful in the way that it allows us to study the universe and make calculations without having to count them all. Okay, so what's in a galaxy? A lot of stars, but okay, sorry, I forgot about that slide. Let's do this one first. Here you are. Here's where you are in our galaxy. We're about there. We're not right in the center. We're not on the outside. The solar system to this scale would not even be visible. And if you away from city lights and you look at the sky, you might see a few thousand stars. If you're a city, obviously you'll see a lot less, but sometimes it feels like the sky is filled with stars and it's countless stars, but actually it's just a tiny fraction of all the stars in the Milky Way galaxy. The stars visible to the naked eye would fit in an area about this size. So there's so much in a galaxy, much bigger than what we can see with the eye, and it's quite impressive. Kind of tend to, if you're starting to feel small, it's normal. So what I was saying earlier is that there are lots of stars in the galaxy, but now we know that most of these stars have planets around them. So again, this is a drawing showing, the stars that we see in the sky and representing planets around them. It's amazing to think about that. Next time you look up at the sky and you see the stars, just imagine that most of them we know now have planets. So everything I told you about the solar system, planets, smaller objects like dwarf planets, asteroids, comets, that's repeated billions of times just in our own galaxy. And we don't see these exoplanets very well. This is definitely a drawing. We can't take pictures of exoplanets like that directly because they're just so far away and we don't have the technology to see them in these details. But this is based on an exoplanet that was discovered, and this exoplanet orbits a binary system, 2 stars in orbit around one another, and there's a planet around them. Okay, just a quick note. I see some of you are pretty excited in the chat, but it does make it hard for me to see questions. So if you could just leave questions in the chat, would make it easier for me. And if you don't want to see the chat anymore, you can close it. By the way, you don't have to see it either in Zoom or in YouTube. There we go. There are some planets that have 4 stars. I don't know which one exactly, but some of them have 2 stars, 3 stars. So just imagine that would be kind of different. We see that sometimes in science fiction, in Star Wars, for example, system with more than 1 star, but definitely those exist for real. We just don't have pictures of them like this, because that's not a picture, that's a drawing, but we can see them in details. In the Milky Way, in our galaxy, we also have lots of beautiful objects. These are nebulae. A nebula is a huge cloud of gas and dust, and many of them they're just beautiful. They look amazing on pictures. So the universe is really beautiful, actually, when you start looking at different objects. So I wanted to show you some of them. These 2 types of nebulae are found in our own Milky Way. This one here is called the Eagle Nebula, and it is a place where stars are formed. So this is pretty amazing to think that this is a huge cloud of gas and dust. We sometimes call it a star nursery. New stars are being formed. So entire solar systems are being formed in this. We also have nebulae where when stars die, in a sense, like they explode or they change at the end of their lives. They don't live the way we do, but they do evolve and change. So this is the remnant of a supernova, a star that has completely exploded. Some of these pictures are false colors. The goal is not to cheat, as sometimes it brings out different details, that it highlights different things, but they are definitely beautiful, and you might have seen them in different places. In the galaxy, you also find star clusters, many stars forming in the same region of space, such as this one. You can see stars of different colors. Some of them are red, some of them are blue. It depends on their temperature. The hottest ones are blue, and the less hot one, I don't say cool because they're still very hot. They're still thousands of degrees, but they're cooler they're less hot than the other ones. So the less hot ones are red. And you can see the colors with the naked eye a little bit, not as much as this. But if you go outside and pay attention to some stars, you might notice difference in colors. And yes, I did see some questions. Yes, some stars are being formed right now as we speak. This is a sort of continuous process of stars being formed, other stars sort of dying, ejecting their gas into space, and that gas can be reused, forming new stars and planet. There's this constant cosmic recycling happening in space. So everything I've shown you so far is part of our Milky Way galaxy. Again, this is our galaxy, a drawing of it. But now let's have a look at real galaxies. This is our neighbor, the Andromeda Galaxy. This is the closest galaxy to our own Milky Way galaxy, but even then it's still over 2 million light years away. So just remember a bit how big a 1 light year is. This is over 2 million light years away. So it's extremely far, and this is our neighbor. Many more galaxies. This one is called the Sombrero Galaxy. It's a beautiful galaxy, spiral galaxy, but seen from the side. So it has a big bulge that we call here in the center, some dust. You can see some dust in the spiral arms. Beautiful pictures. Here's the famous Whirlpool Galaxy, M51. You can see it has a sort of another galaxy here on the side, but the two are probably interacting. And one thing that really strikes us when looking at this picture are the pink regions everywhere. These are some of those nebulae, the huge clouds of gas and dust. And the reason they're pink is actually because they have a lot of hydrogen in them. Hydrogen, we find on Earth a lot. I mean, water is made of hydrogen and oxygen, But when you have hydrogen gas in space and when it glows pink. So we have a lot of beautiful pink places and galaxies because those are nebulae. Okay, so I see a lot of questions happening right now. Yes, we think many galaxies, spiral galaxies, have black holes in their core, in the center. Well, that was another galaxy I wanted to answer. Anyway, so yes, there's lots of galaxies out there. I'll show you other ones. Galaxies can collide and they can sort of interact. When I say interact, because gravity, like each galaxy is sort of a big gravitational pull. It's pulling the other one towards it. Stars don't really hit face to face in a sense, but there's a lot of space between stars. So everything will change and gravity will distort everything. This one kind of looks like a rose actually, or other galaxies colliding here. I saw a question a lot earlier about the Orion Nebula, and the Orion Nebula is also a place where stars are formed. This is one of the most famous nebula. I didn't include a picture of it here, but you could go check online, Orion Nebula. It is a beautiful nebula as well. And this is a picture that is really amazing when you realize what it is. And this image, you have some of the furthest galaxies that we can observe. So when you look in space, I'll come back hold on. I'll come back a little bit to explain this. Let's say when we took this picture, the telescope that took this picture is where Earth is. This one was taken by the Hubble Space Telescope. So it's in orbit around the Earth, but it's still very, very close to the Earth. It's not in space very, very far away. It's in orbit, it's in space, but close to the Earth. So we don't travel to those galaxies to take pictures of them. We look at them from here. And when we look at them, we definitely see some things that are closer to us. For example, if I look out the window here, I'll see some things that are closer to my house and some things that are further away. So here we can see some stars, which are within our own galaxy, so much closer to us. We can see this galaxy, which was the focus of the picture, but we can also see very small galaxies in the background, like these ones here. So these are much further away. So if we look at this picture here, we have a few stars. The ones that have spikes are stars in our own galaxy that just happen to be in this field of view. When we look up, that's where we're looking. But all the other points that you see are galaxies, entire galaxies, very, very far away. So everything I've shown you so far and how big one galaxy is, you have that repeated probably thousands of times, or at least hundreds of times in this image alone. So it's pretty amazing when you think about it, how big the universe is. And this is actually just a tiny, tiny part of the sky when we took that picture. So you can have that repeated all over in all directions that you look at. So you might feel dizzy. It kind of makes you feel extremely small when you see this. But I like to highlight that it's amazing that even though humans are stuck basically on Earth, we can't travel very far. We're able to study things very far away. We have the creativity to build instruments and to understand and do the math and understand things that are so far away, we would never even dream of traveling there. So we may be small in size, but we're definitely big in creativity and intelligence in what we can do with science. I see a lot of, anyway, every time I look up to the chat, I see new things about aliens. We don't know if aliens exist. As you can see, space is big. There are lots of possibilities out there, lots of interesting planets to study, but we don't have the definite answer if they exist or not. This is one of humanity's biggest question, and we have scientists working on trying to find the answer. And we'll discuss that again in another session in more details. I just want to finish with this picture, which at first you might be sort of, what is that, right? Well, it's actually interesting because this little point right here is our planet. This is the Earth. This is, all we have basically to live. This picture was taken by a spacecraft that was leaving the solar system. It turned around and took this picture. And in that frame, we could see planet Earth. This is just the sunlight being reflected in the camera. But it kind of makes you think differently about our planet when you see it this way. I find that astronomy is fascinating because we look very far away. We can see things that are very, very far. But at the same time, it makes us look at ourselves and realize, oh, Earth is very small. We're all, citizens of planet Earth. before being from different countries. You know, whatever country you're from right now joining us live, then, you know, we're all part of this little point there. All humans that have ever existed, all lived their entire lives on this little dot. And, you know, that's all we have too. So we have to take care of it. On this scale, the resources that we have, air, water, seems pretty limited. So there's definitely good things to think about. I will send you, again, I will add link on the website about today's session. You can have a look at the different simulations I will show, and I will send you a link to a beautiful text written by Carl Sagan about this image that we call the pale blue dot, which I really like. So this is where I am for today. I took you very far away. We came back to look at Earth, and I might take a few minutes to see some of the questions that have been, maybe if some questions come back very often, we'll look at that. I will stop sharing for now. Okay. Hopefully you can see me now. Thanks a lot, everyone, for joining. And like I said, we will be doing this every day at 2 p.m. Eastern time. I'm sure many of you are in different time zones, but same time as today. In the next few, at least 2 weeks, we'll see after that. Go to the website where you had all the information, and we'll be posting some links related to today's talk, and hopefully you can browse a few things on your own and check out some of the interactive websites that I will provide. So thanks a lot for joining. Tell your friends if they want to come next time. It's free, it's online. Tomorrow there's a question. So tomorrow we will be, I will be showing you, well, actually it won't be me. It will be my colleague Mike Reed, and he will be showing you what to view in the night sky. So I think astronomy is awesome because everyone can go outside and look a little bit. You don't have to go far. I know from cities it's not as obvious, but there are lots of things even from cities that can be seen. And I know right now we're sort of asking in many places around the world to stay home, but even just on your balcony or hopefully in your backyard, you can see a few things, especially Venus. So anyway, if you want to know what's happening, what we can see easily in the sky, come in tomorrow and Mike will tell you all about that and show you how to use the planetarium software that's free online. So there you go. That's the goal for tomorrow. Oh, there are some weird comments going on. Someone liked the Orion's Belt and Orion Nebula, I think. Okay. Thanks a lot, everyone, for joining. I think we will stop here and we will see you tomorrow.